Okay, so everyone, today I'll be doing the 3.2 chemistry quiz for the periodic. It's easy quiz. Yalla, question one. Which of the following equations show that the underlying substance is a base? Now, we know that a base reacts and gives off OH minus ions. So once you have this, straight away it's a base. Okay, let's see what we have. And keep in mind that, for example, if you have NaOH, that's a base. If you have OH in general, it's a base, most likely. As far as we're concerned, it's a base. I don't know about A level. I don't take A level. Um, okay, so CaOH, obviously that's a base. OH ions, it gives off OH ions, and NaOH, it has hydroxide in it, and it gives off OH ions. Now, if you check all of them, this is an acid. It gives off hydrogen ions. Let me recap what we know about acids and bases. Acids give off H plus ions. Okay, and bases give off OH minus ions. This is basically what you need to know. So in general, if you have H something, let's say hydrogen nitrate or hydrogen chloride, HCl. HCl is going to be an acid if it has hydrogen and it gives off hydrogen, it's an acid. But if you have NaOH, for example, which the equation of is down here, NaOH in water gives Na plus and OH minus. If you have OH minus, it's a base. Okay, question two. Which of the following bases are amphoteric? Okay, this one I'm gonna need to explain. So we have our oxides. Okay, they're into four categories. We have this category here, and let's say this category here. Let's say this category here, and I'll just make one more here. We have this category here. Okay, so we have basic oxides. We have acidic oxides. We have amphoteric, which I'll just label as AM, and we have neutral, which I'll just say as N. Okay. So, I'll start off by describing the acidic and basic oxides. So, for our basic oxides tend to be metallic oxides. So, just say metallic. I'll write metals or I'll just write metallic, no problem. Metallic. There we go. Okay. So, for example, K2O, MgO, uh, CaO, whatever. It goes on. Um, Basically, these are basic. Now, most oxides that are metallic are basic, except for the exceptions, which are in the amphoteric, which I'll discuss later. Okay, so I'll go back to it later. Let me just describe what an acidic oxide is. Acidic oxides are non-metals, all right, NM. Okay, these include non-metals, so CO2, SiO2, SO2. And there's one I want you to remember just in case they bring P4O10. Okay. So basically, what acidic oxides are, or non-metallic oxides, they are non-metals, akid, and they react with bases. So here they react with bases. And the basic oxides or the metallic oxides, they react with acids. Acids, there we go. And these tend to produce either the metallic oxide plus the acid will give you a salt. Okay, just keep that in mind, or metal hydroxide, doesn't matter. uh or actually, no, my bad, the metal oxide with water will give you a metal hydroxide. So let's write it MO. That's a MO for metallic oxide plus hydrogen, or water, sorry, H2O, will give you metal hydroxide. So I'll write MOH. Okay, and metal oxides, MO, plus an acid reacts to give salt, which I'll say as S, plus H2O. Okay, so this is for the basic. So this is for this. Now, acidic oxides or non-metallic oxides. Non-metallic oxides, all right, NMO plus acids or hydrogen or dihydrogen oxide, which is water. What am I saying? H2O gives an acid. Just keep these in mind. These are some equations you have to know. Okay. And these are what you have to know for metallic and non-metallic oxide. Now, on to amphoteric and neutral. Neutral, I'll leave it to the end. Neutral is really easy. I'll actually leave amphoteric to the end. I'll discuss neutral now. Neutral, neither neither reacts with an acid or a base. So you can these are memorization: H2O, N2O, NO, and CO. Okay, just memorize them. Amphoteric, and there's nothing really you need to know about them other than their chemical formulas. Amphoteric, they can either react with acids and bases, both of them, doesn't matter. Okay, ZNO, these include ZNO, zinc oxide, lead oxide, and Al2O3. Okay, these are your general oxides. This is what you need to know for the periodic. So now that you have this, you can get started on this question and a few questions after it. Which of the following oxides are amphoteric? Again, we said amphoteric is zinc oxide and Al2O3 and PbO, as I said here. Okay, which of the following oxides is basic? Remember, basic metallic. So if it's not an amphoteric solution, it's not amphoteric oxide, and it's metallic, uh it's gonna be basic. So K2O, yes, that's correct. Al2O3, this is amphoteric, so no. Zinc oxide, amphoteric again, and this is non-metallic, and it's not neutral or amphoteric, so it's gonna be carbon dioxide, which is acidic. Which of the following oxides is acidic? Carbon dioxide. Okay. Question 3. Which of the following oxides only react with HCl? HCl is an acid. HCl, acid. Remember we said it gives off hydrogen ions. Okay. So again, bases react with acids. So you're gonna find the basic oxide, which is MgO. SO2 non-metallic. So this is gonna be acidic. This is gonna be neutral. It's one of our neutral oxides. This is amphoteric, and amphoteric reacts with both acids and bases. But here they said only, not HCl and NaOH, which is part 3 here. Um, they only said HCl, so no. And this one's acidic, so obviously not. Which of the following oxides only react with NaOH? Okay, NaOH, that means it's a base. Base, that means it's gonna be an acidic oxide, which is non-metallic. So zinc oxide, amphoteric, no. Nitrogen dioxide, neutral, no. Or dinitrogen oxide, no. Magnesium oxide, this is basic, so no. And then these two non-metals, so they're fine. Okay. Which of the following oxides reacts with both HCl and NaOH? This means amphoteric. So AM. ZNO, nothing else here. If they had Al2O3 or lead oxide, PbO, that's when you would choose another one. Which of the following oxides neither react with HCl nor with NaOH? So this is neutral. It doesn't react with any of them. This is an acidic oxide. It reacts with NaOH. This is an acidic oxide. Also reacts with NaOH. MgO reacts with HCl. It's basic. This is amphoteric. It reacts with both. So this is our only option. Okay. Question 4. Choose the correct answer to identify the nature. MgO. MgO is basic metal. Carbon dioxide, non-metal, so acidic. Copper oxide, again, copper is a metal, so it's going to be basic. N2O is one of our exceptions for the non-metals. It's going to be neutral. Carbon dioxide again, or carbon oxide, sorry, um, neutral. Carbon monoxide. Zinc oxide, amphoteric, reacted both. Sulfur dioxide, acidic, non-metal. Al2O3, amphoteric, it's an exception. And CaO is basic calcium oxide, that's a metal. So it doesn't belong to any exceptions. Okay. This بصراحة I feel like it's common sense, but I'll go on with it. Acids. Before this I'll explain some properties of acids. Acids, so I'll label them A. Sour, that's one of their characteristics. Taste. This is for taste. I'll write T. Produce. I'll write P. Produce hydrogen ions, so H plus ions. And this is basically what you need to know. And now for our bases. Bases tend to taste bitter and feel slippery. Yes. Both sodium carbonate and ammonia produce hydroxide ions. Sodium carbonate and ammonia are bases. Keep in mind. For these two, ammonia, I feel like some people just struggle with it. They might think it's an acid because it only has H, it doesn't have OH. NH3 and NH4, they are bases. Just keep that in mind. Even though they don't have hydroxide in their actual chemical formula, it's fine. They are they only have hydrogen. It's fine. They are bases. Sodium carbonate, NaCO3. Um, these two, uh, as well. Just memorize it. It's a base. But if you were to do the chemical reaction with water, you'll find that it will give off OH ions. And an aqueous solution, acid reacts with the base to produce water. This is true. It's aqueous. Keep in mind. Okay. Question 6. Three test tubes are contained. Okay, this is testing for oxide. The oxide in tube 1 is MgO. Let's read the description. The solution in tube 1 turned wet litmus paper to blue. Again, metallic oxides are bases. Non-metallic acids. And neutral oxide. No, let's just say none. Okay, so the oxide in tube 1 MgO أكيد because metal oxides are bases and bases turn red litmus paper to blue, so this is correct. The oxide in tube 2 wet litmus paper to red. Again, this means it's an acid, and so you choose the acid which is SO2 in this case. Okay. Now the third test tube, the solution in the third test tube has no effect. No effect, that means it's neutral, it doesn't change. So CO. Again, remember, our neutral is H2 and H2O, N2O, CO, and NO. A student performs the tests below to identify unknown solutions A, B, and C. He places a piece of magnesium metal on whatever, blah, 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 formation of bubbles. Keep in mind, formation of bubbles. This also means effervescence. If you see it in your exam, effervescence. I don't know how you spell it. I'm not. I wasn't that good at spelling it when I was younger. Okay, effervescence. That means a release of gas is happening. This basically means that gas is being released. That's an observation. Then he inserts a lit splint into the tube. As a result, a squeaky pop sound is found. So this means a squeaky pop sound. This means there's hydrogen in it. Okay, keep this in mind. Pop sound, hydrogen. Then number 2, he dips red litmus paper into sample solution B as the solution. Okay, red litmus paper turns blue, so we know this is basic. And no effect. This is neutral. Okay, such much. We'll start with solution 3 since it's the easiest. Solution C, or solution C is H2O. H2O is neutral, and it has no effect. Keep in mind. So we match that. Now, solution B. Solution B turned the red litmus paper blue, which means it's a base. Oh, this is acid. This has hydrogen. This is acidic. Hydrogen nitrate. It contains hydrogen. So this is acidic. So NaOH. This is obviously the most common base you're gonna find. NaOH. Just keep it in mind, and you should be good. It's a base. Now solution A. You see hydrogen here, and that's basically how you identify really, because effervescence or the formation of bubbles could also mean carbon dioxide's forming. But if you get this as a result of the splint, if you hear a squeaky pop, this straight away means it has hydrogen. So basically, you find this by process of elimination. Okay, question 8. An operational definition is a set of actions to confirm whether or not a substance fits the definition. Okay, operational, this is its definition. It's a set of actions that can be performed to confirm whether or not substance. So basically, this is practical. This is a practical definition. You do experiments in the lab to get whatever you're gonna get to get the operational definition. Now you also have conceptual definition, which we'll see in a I think in the question right after this. But we'll see now. Yep. Question 9. Never mind. Examples of acids. Again, anything with hydroxide base, so NaOH base, MgOH is a base that leaves hydrogen chloride and hydrogen nitrate. Nitrates are generally bases, and again they contain hydrogen. So a conceptual definition is a definition based on the theoretical concept and not on operations performed in laboratory. You can see it; it's in the sentence. Theoretical concept, so conceptual. Generally, conceptual definitions, all right, form into operation definitions. Because how you get your operation definitions, you get a conceptual definition, you do some tests to test if the definition is correct, then you develop an operation definition based on it, like logically speaking. So this is how you differ between those two. Question 11. Select the base. Akid NaOH and NH3. Again, NH3 is a base. Ammonia table and NaOH is also a base. Hydrogen nitrates an acid and hydrogen chloride is an acid. Question 12. Uh, select the base again. No, I think yeah, there we go. That book. I'm gonna have to close out of and open it again. There you go. Or I'll go back to it. Okay. Element X is on the right hand side of the periodic table. It forms an acidic oxide that's non-metallic. Again, remember your periodic table, or I'll just pull it up right here. Periodic table. Here you go. Okay. Generally anything after this line, so which is our semi-metals. Anything after this line is a non-metal. To the right of it's a non-metal. To the left is metals and transition metals. So that's all you need to know. If it's on the right hand side, non-metal, this is basic science. So straight away you put out that is non-metallic. And now that you know that non-metallic oxides are acidic oxides, so you write and it forms an acidic oxide. Now back to this question that finally works. Check if the elements whose oxide reacts with bases only. Bases only. That means that it's acidic. So this is non-metallic. NMO, non-metallic oxide. Carbon's a non-metal. This one's a metal. Calcium's a metal. Silicon's a non-metal. You circle it. It's a transition metal, but just put it. Na. Na is a metal. Copper is a metal, and zinc's a metal. So it's only these two. Okay, that's the end of 3.2. Good luck, guys. I'll be making 6 point whatever in a bit. Good luck.